In today's lesson, we're going to be looking at the processor and its most important parts, in particular the control unit, the ALU, and the registers. And by the end of each lesson, you should be able to tell each of these apart. And there's a little quiz for you to do, so I know that you can do it. It's 10 questions. I think 6 of them are multiple choice, so it's not that hard. What is the processor? Processor is the brain of the computer. Everything has to go through it at some point or another. Every instruction, that is. It's measured in gigahertz, or hertz, sorry. 1 hertz is 1 instruction per second. So if you have a 4 gigahertz computer, that means it does 4 billion instructions per second, for example. Like I said, these are the main parts we're going to be looking at, but first I'll get a diagram up. So, I mean, it's a pretty simplified diagram, but the whole point of this is that you've got your input devices, so let's say keyboard, mouse, microphone, whatever, and all of these inputs, all the data from that is going to be interacting with these two parts. Well, it's going to be interacting with all the parts, but the important thing to take away from this is to get to the output devices, so your screen or your speakers, stuff like that. It has to go through the control unit. So already we should be thinking that the control unit it's really important in the role of the processor. So what is the control unit? It controls the timing and order of instructions. So there's lots and lots of instructions being fired at the processor at once. It is the control unit's job to decide what is the most important instruction. So if an error pops up, then it has to deal with that error first, and that's why you'll see an error box pop up on your screen. If you've just booted up your computer and it's going a little bit slow, this is actually because the control unit is trying to do too much stuff at the same time. So if you've got programs, so I know one I find really annoying is Spotify. Spotify by default, unless you turn it off, tries to boot itself up automatically. I think stuff like Steam does as well. If all these things are booting up automatically, the control unit will try and give each one like a little bit of power each, whereas sometimes you don't really want that, but it is the control unit's job to try and evenly distribute it. So it will prioritize certain things. And like I said, every instruction is passed into the control unit. So that is back to this diagram here. We've got our keyboard there or whatever, or me speaking right now. It will go to the control unit and it will come out through your speakers. So what else? Arithmetic and logic unit. This is probably the easiest one, I think, to remember because it's in the name and what it does. It performs the calculations and the logical decisions. In other words, for calculations, the arithmetic, and, well, the decisions, the logic. So by calculations, it just adds numbers up together. A computer actually can't take away. It just adds 2 negative numbers together. So and it just keeps adding that way. It can't multiply either. It will just add over and over and over again. So really, when I say performs the calculations, we're really saying perform the additions. Logical decisions is just comparing 2 numbers. Just like an if statement, you're saying if one thing is bigger than the other, and that's it really. Last part is the registers. It's a temporary storage space for information, for data. It's actually the fastest type of memory, and it's the fastest because it's built onto the processor itself, so it's really easy to find, and much easier than getting RAM or from a hard drive or anything like that. It's literally built onto it. A standard computer, so a 64 bits, kind of the standard now, has 16 of them, and they don't have a lot of data. They don't have a large size to hold data, but it's just because they're only holding a few instructions. Saying that, its size is determined by something called its word length, and although I've just said it doesn't have, it's not a very large piece of data, it doesn't look like that when you see the next slide. So the word length is the largest number a computer can store in its registers. So if you have a 32-bit computer, these are computers that were popular 10, 20 years ago, you're going to have 4,294,967,295 as your largest number. So we've talked about binary before, where if you've got an 8-bit computer like an old Nintendo, the largest number it can store is 255. This is the largest of our 32 bits because it keeps doubling every time it goes up. But we'll just say 4 billion, and I'm not going to try and say this. I believe it's quintillion. So yeah, it's a 64-bit computer. The largest number it can store is 9 quintillion, which is apparently a small number. But yeah, so that is the largest size each register. So overall, we have the one that he's kind of like the boss of the processor, gets the timing of instructions. We've got the one that adds things up, that compares them, and we've got the one that stores data temporarily until you use it later. So that's me saying everything really. All we've got to do is this little quiz. If you click on it, and like I said, it shouldn't take you long. All these are mainly 1 or 2 word answers, and then once you finish that, just hit submit. Please give me your honest feedback on how you feel this has went. It will help me with revision later, just to see where everybody is, and of course your answers will help me with that as well. Right, thank you.